On behalf of the SCSTE, I would like to welcome all viewers and especially our dear students to this online class, and I hope that you will gain a lot of benefit from this online class. And today in this class, we will be continuing from the chapter Physics, which is chapter 2, where we left out in the first class. Let's begin. So, on the previous class, we have learned about the different parts and the functions of the human eye. Alright, so now in this class, we will learn about the 3 common defects of vision. Alright, but before we go into those defects, first we will look at a new term which is called accommodation of the eye. So, this new term is called accommodation of the eye. So, what is the accommodation of the eye? It is the process by which the ciliary muscles, alright, can alter the focal length of the crystalline lens so that the images will be focused clearly on the retina. Alright. So now let's look at the 3 common defects of vision. The first common defect of vision is myopia or short-sightedness. Myopia, or in other words, we call it as short-sightedness. So this is a common eye defect, alright, in which a person suffering from this defect can see only the near objects clearly, but cannot see objects which are lying very far clearly, alright. And the cause of this defect is because of the elongation or the increase in the size of the eyeball. And hence, because of the elongation or increase in the size of the eyeball, the image will be formed in front of the retina. Alright, instead of at the retina itself. Alright, so now let me explain to you that by drawing a diagram. It will be more clear if I draw a diagram. So suppose we have a normal eye like this. Suppose this is a normal eye. This is the cornea. Alright, I won't draw the other parts of the human eye. Alright, this is just a simple diagram to illustrate myopia. So suppose this is the retina, alright, we have the retina. This is a normal eye. And if a person is suffering from myopia, the eyeball will be elongated or will be increased in the size. So you will have an eyeball somewhat like this. Alright, we clearly see that this eyeball is, it has a larger size than the normal eye. So, this eyeball that we just mentioned, this is a myopic eye. Or this is an eye which suffers from myopia. Alright, so when light rays, alright, coming from a distant object, entering the cornea, alright, they will get refracted. And we also have the crystalline lens. So this is the crystalline lens. They will get refracted or bent. And further, the crystalline lens also refracts the light from the cornea to focus it on the retina. Alright. But in case of a myopic eye, when the light rays enters, alright, the myopic eye, it will be converged on the front of the retina. So suppose these are the light rays. When it enters the cornea, it will get refracted or bent. And further, the crystalline lens bends also these light rays, and hence, because of the elongation of the eyeball, alright, these light rays will be formed in front of the retina. This is the retina. And this is the front of the retina. So we clearly see that in a normal eye, the light rays on entering the cornea falls exactly at the retina, but in a myopic eye, the light rays coming from an object, they fall in front of the retina because of the increase in the size of the eyeball. So that is why we cannot see objects, alright, clearly, alright. So now let's move on to the next defect of vision, which is hypermetropia. So the next defect of vision is what we call hypermetropia or long-sightedness, alright. So this is also a common eye defect, alright, in which a person suffering from this eye defect, which is hypermetropia, can see the far-off objects clearly, but cannot see the near objects clearly, alright. And the cause is due to the contraction or the decrease in the size of the eyeball. It is opposite to myopia, alright. Let me draw a diagram. Suppose we have a normal human eye. Right, so this is a normal eye. And suppose we have a hypermetropic eye. So, we have a normal eye and a hypermetropic eye, or an eye which suffers from hypermetropia. So we clearly see that in a normal eye, this is the size, alright, suppose this is the size of a normal eye. But in case of persons who have this defect of vision, which is hypermetropia, the size of the eyeball gets contracted or gets reduced, alright. So suppose the light rays, alright, on entering the cornea, coming from near objects. Suppose this is an object, the light rays on entering the cornea. So we have a crystalline lens somewhere here. Alright, and the light rays on entering the cornea gets refracted or gets bent. And then the crystalline further bends those light rays. So the cornea bends those light rays, alright, coming from a near object, and then the crystalline lens further bends those light rays so that the image will be formed at the retina. This is the retina, alright. But in case of a hypermetropic eye, if we have a object which is near, and suppose we have the crystalline lens somewhere here, when the light rays comes, alright, from the object and enters the cornea, it gets bent. And then the crystalline lens further bends those light rays. And because of the decrease in the size of the eyeball, those light rays will get focused behind the retina, because we see that this is the normal human eye. This is the position, alright. This is the position of the retina. And so in a normal human eye, the light rays are formed, coming from the object, are formed exactly on the retina. But in case of a hypermetropic eye, the light rays, alright, will get converged. But because the size of the eyeball gets decreased, so the light rays will be formed at the back of the retina, alright. and so we cannot see the object which is coming from here, alright, clearly, alright. The image of the object will not be clear, or it is blurred, alright. Alright, so now let's move on to the third defect of vision, which is called presbyopia. So this is also a common eye defect, but this eye defect is commonly seen in persons with an old age, alright, or in elderly persons, alright. And persons suffering from this defect can see the far off objects clearly, but cannot see the nearby objects clearly, alright. So this defect, presbyopia, is similar to hypermetropia, because in hypermetropia also, a person who is suffering from hypermetropia can see the far off objects clearly, but cannot see the nearby objects clearly, alright. So in presbyopia, alright, the only difference is that in hypermetropia, suppose we have, this is the normal size of the eyeball, alright, this is a normal eye, but in hypermetropia, the size of the eyeball gets decreased, alright, and hence the light rays coming from an object will be formed at the back of the retina. But in case of presbyopia, the eye remains the same. The size of the eye remains the same. But due to the old age, alright, the ciliary muscles, alright, these are the ciliary muscles, gets weakened, alright. The ciliary muscles becomes weak, and also the flexibility of this crystalline lens also gets weak, and hence it cannot focus the light rays coming from far off objects to be formed at the retina, alright. So it may form somewhere here in front, or it may form sometimes behind the retina because of the weakening of the ciliary muscles, alright. The size of the eyeball remains the same, it's just because of the weakening of the ciliary muscles and the flexibility of the crystalline lens, alright. So that's the only difference between presbyopia and hypermetropia. Now presbyopia, I've already explained to you the cause. Now I will explain to you how these three common defects of vision, alright, are corrected, alright. So now, in a myopic eye, because the light rays coming from far off objects, alright, get formed in front of the retina, so we will see now how can we correct this defect of vision, alright. It is corrected by placing a concave lens of suitable focal length. So if we place a concave lens in front of the myopic eye, because the function of the concave lens is to diverge the light rays, alright, so it will diverge these light rays coming from a distant object, and on entering the cornea and the crystalline lens, suppose we have somewhere here the crystalline lens, now on entering the cornea it will get bent, these light rays will get bent, and then will get converged exactly on the retina because of the help of the concave lens. Because in a myopic eye, if we don't put a concave lens, alright, then the light rays coming from the distant object will not get converged properly to form the image at the retina. Instead, it will be formed in front of the retina. But when we put a concave lens, alright, first of all, it will diverge, alright, it will diverge the light rays, and then it will get converged at the retina, and hence we can see the object clearly, alright. Now, we know that in a hypermetropic eye, the light rays coming from the near objects, alright, gets formed behind the retina, and hence we cannot see the image of that object clearly, alright. So to correct this defect, we place a convex lens, alright. We place a convex lens in front of the hypermetropic eye, and so when the light rays, alright, coming from the near object falls on the concave lens, it will get bent, alright, or it will get refracted, and then on entering the cornea and the crystalline lens, suppose we have the crystalline lens somewhere here, it will further get bent, alright, and then the image will be formed at the retina. If you don't put a convex lens, this is a convex lens, if you don't put a convex lens in front of a hypermetropic eye, the image coming from the near object will be formed behind the retina, and hence we cannot see that image clearly. But if you place a convex lens in front of the hypermetropic eye, the light rays coming from the near object will get bent first by the convex lens, and then on entering the cornea also will get bent, and then on entering the crystalline lens also will get further bent, and hence we can focus the image on the retina, and so we can see a clear image of that near object. Alright. But in case of presbyopia, the main cause of presbyopia is because of the weakening of the ciliary muscles. Alright. And hence the light rays coming from far off objects or near objects cannot be focused properly on the retina. So that's why we cannot see clearly, alright, in case of persons suffering from presbyopia. So persons suffering from presbyopia, sometimes they suffer both from myopia as well as hypermetropia, which means that those elderly persons, sometimes they cannot see both the near objects as well as the far off objects. Alright, so how do we correct such a defect? Alright, such a defect is corrected by using a bifocal lens. Bifocal lens. In the bifocal lens, suppose this is a bifocal lens, the lower part is made of convex lens and the upper part is concave lens. So when an elderly person wants to look at an object, alright, at a near object, the light rays, alright, on entering the convex lens will get converged properly on the retina, and hence the old person can see that image clearly. And so when the old person wants to look at far away objects, the light rays, alright, on entering the concave lens will get converged properly on the retina due to the help of the concave lens, and hence we can see that object clearly. Alright. So with this we come to the end of this class, and we'll meet again on the next class. Till then, stay safe. Thank you.